This is Møller Nielsen from Java Code Geeks, and I'm going to teach you how to write clean, efficient code using the Docker engine. If you have tried to write a program that only runs on your machine, and then when you try to move it to production maybe, or maybe to one of your colleagues' machine, then it does not work, then the Docker engine will definitely be something for you. Now, complementary to this video, we will have related articles and links in the description below. Please take the time to like, subscribe, and hit that notification bell so you know when we have new stuff coming up. Now, without any further ado, let's get started. So what is Docker? Docker is a virtualization technology where you can create containers based on Docker images. So it is almost like a virtual machine, just a bit more lightweight. And you can install the Docker engine on any kind of operating system. The most common operating systems out there, like Mac OS, like on Linux, and also on Windows. And this means since the Docker image, which is a recipe for the file system and what should be on this virtual machine, this will actually run the same way, no matter which computer you run it on. If you run it on your own, maybe it's a Windows machine, then when you run the same Docker image on a Mac machine afterwards, then it will run the same way. This also means that when you put something into production, you can be much more secure and safe, that it will run the same way as it did when you ran this image on your own machine. So it is a virtualization technology, a bit more lightweight than a real virtual server. Let me try to sketch out the workflow that we usually see when we are dealing with the Docker engine. Usually we have some kind of application that we have created. We have created some kind of, maybe we have a cool jar file with this cool application. It could be a web application that we have. We want to place this. We want to put this into production. We want to be able to put this on our test environment or development environment. And the way we can do that is by creating a Docker file. The Docker file is a recipe for how the Docker image should look like. The Docker file will mention which operating system should it spawn from, because it always starts from something. They can start, for instance, from an Ubuntu version. So that means that the base image type will then be Ubuntu, for instance. Or we can use a more lightweight operating system like the Alpine if you want to optimize your Docker image a bit. So that is always the first part of the Docker file, and then at some point, then you want to add your application to the Docker file, to the image, and thereby to the image, and that is done with this copy command that we have right here. So first you can create your application, then you create your Docker file, and then you can build that Docker file with the Docker tools into a Docker image. A Docker image is always located inside a registry, and per default it will be located in the registry where you actually built it. That means on your own machine, if you build it on your own machine. If you have like a Jenkins machine to build it, then of course it will be, then first of all it will be located on the Jenkins machine's local Docker registry. And then you might want to push that to a common Docker registry. That's very normal that inside a company, then you have a company Docker registry where you then can push the local Docker image to. Because then when you have pushed your Docker image to that registry, then you can have an engine running inside a production environment or inside a development environment or test environment. And that Docker engine can then spawn containers. It can create containers, Docker containers from that Docker image file, because the Docker engine has access to the Docker registry. So that is the flow. I know it is a whole other world, but it's actually not that difficult when you just see this drawing right here. We have an application, we have a Docker file, we have and this leads into a Docker image, and this image can then be pushed to a registry, and from that registry, this image can then be taken, and then containers can be spawned from this image, and then the application will actually run inside this Docker engine. Of course, there's a lot of more stuff to it. This is a basic tutorial because there's a lot of stuff like what about networking? Per default, all of the containers can actually see each other, and they can actually reach each other network-wise by accessing the name. But that's a whole other story. The important thing here is that it is the Docker engine that runs on your machine and the Docker engine that actually runs on the production environment. Those are both capable to run the exact same Docker image. And that's why there will be no surprises when you place your Docker. Although there should not be any surprises when you place your Docker image into production and containers are being spawned from that image. Now let us try to see some hands-on examples, because of course the first thing you need is actually you need to install the Docker and the Docker engine on your own machine, and it is happily for us, and it's actually free. It only costs a bit if you want the larger subscriptions that they have, and definitely to begin with the free version is more than enough for you, and yeah. And then another thing that we have is that we have a common Docker registry, because even though that we actually have this company Docker registry, then there's something called Docker Hub, where all the official database vendors, database providers, and just application providers in general, they are placing their images on the Docker Hub, and that means that we can download those by default. And then we can use those just out of the box. And that is exactly what I am going to use right now. I've created a folder right now, and I'm using VS Code to change my files right here, just because it is very lightweight, the VS Code. You can use, of course, whatever IDE you want to. There are a lot out there that actually supports the Docker files and also supports shell scripts, which we are using right now. First of all, let me just show you a short agenda for what I want to show you here. First of all, we will look into, we just saw the intro, the Docker engine. What is the Docker engine? It is something that can run an image and spawn up a new container, which is a kind of a virtual machine. Then we should try to Docker run something, and that is the point where we are right now. Then we will try to map out a port from inside the Docker container to our local machine, so we can actually access the application that runs inside this Docker container. Then we will create our own Docker. We will actually create our own Docker image that can then echo out "Hello World" out in the console, and then we will try to run something as a daemon, and then we will see how we can actually attach to a running container, and also how we can debug when something is wrong. What can we do? And then we will check how to actually create some volume mappings. If we do not volume map anything inside the Docker container, that means that would mean that when a container stops, then all of the files that are being placed inside the Docker container, those would just be lost, those would be deleted. But if we create a volume mount, then we can actually persist those files into the mount, and then next time the Docker container starts up based on image, then the files will still be there. That is the difference. And then in the end, we will try to look at how we can optimize the Docker image by changing the underlying operating system from Ubuntu to Alpine. Let us just get started. So in the bottom, I have a terminal, and I'm using WSL. I'm using Windows and then WSL. That means Windows Subsystem for Linux. And I have my folder right here. And there are some Docker commands we can write just to test that my Docker is running as expected. If you run Docker ps, then you'll get a list of all the running containers that we have running right now. And I don't have any containers right now. And then you can write Docker images. Then you'll get a list of all the images that you already have on your machine. And sometimes it can be a good idea to delete those images. You can add a delete, you can add a remove argument, and then you can remove the images because they can actually take up a lot of space. But you can actually see here I have an Nginx. I have an Nginx image lying around that actually takes up 141 megabyte. Sometimes you will have images that actually takes up gigabytes instead. So clean up the images once in a while when you have been playing around with too many stuff without cleaning up the images after you. So those are basic commands. Then if you want to run something, then we can do that with the docker run command. And if we don't know what to run, then we can look up applications on Docker Hub on hub.docker.com. Then you can search for the application that you want. If you want a database like a Redis database or MySQL database, then you can just search for that. In this situation right here, we just want an Nginx web proxy server. And then we want to see that it actually delivers some HTML for us. And when I search for Nginx, then I will get this result right here. Then I can actually see how to run it inside the documentation right here. There's some documentation, how should I run it. And here there's a lot of good tips and tricks to how to actually run it. I can run it as a daemon like they do right here. And how to expose the port. But now we will just keep this very, very simple. So I'll just call the run Nginx and then the colon and then a tag, because all of these images right here, they have something called tags. Most images, they actually have a tag named latest. And if you don't give a tag when you write the docker run command, then it would actually look for latest. So sometimes it will be okay just to run docker run Nginx. Then it will actually look for an image that is tagged with the latest. A lot of times the tags are used to set the version. So maybe you want a specific version of your MySQL database. Then you want to use that tag that matches that specific version, your database, of course. So, and there's a lot of good documentation, a lot of good help especially for beginners that have not tried to run Docker before up here. Let us now try to run something. So we have a command right here that says docker run. Then I say -IT for interactive and terminal. And then we can skip out. Let us skip out the port first. I will write this in by hand in the terminal right here. Docker run and then Nginx. If I don't write anything, and just write Nginx and then colon latest. I could leave out the colon latest because it will try to look for that anyway. We can do that the second time. But now let us just try to run docker run Nginx like this and see what actually happens. Now what I can see is actually this is actually the log from inside the Nginx that I have right here, and my Nginx is actually running now. That means that now I have actually one running Nginx container. I cannot access from outside because I have not mapped ports from outside to inside of this container right here. But how can I see that this container is running then if I cannot access it from the outside, you might ask? And the way to do that is to use the docker ps command that we just learned just before. This will give us a list of running containers. And here we can see there's a container ID. I can delete the running container if I want to by ID. I can also execute commands on the running container by using the ID right there. And here I can see the command is right there, and this is the image type, the next latest. This is when it was created, and this is when it got the last status. This is this right here, the ports. That is just a documentation. This is just meant for documentation. This means that the developers of this image are telling me that they are placing something on port 80, and they think that I should actually map out port 80 to something on my local machine, because then I can actually reach the HTML that they are serving. So this is just for information. It doesn't have any technical effect at all. It is just documentation from the developers. And this name here that we got in the end, that is something that is just being generated because I did not name my container. You can also name the containers, and then you can look for those containers afterwards. If you don't name your container, then you will just get a random name that will be generated right here. So I'll go back to the first terminal right here. If I press Control-C now, because I'm not running as a daemon, I'm actually running in interactive mode. This means that if I'm breaking this, then my container will actually die. So if I run docker ps now I can see that my container is actually gone. If I run -A, then I get all of them. Then I also get the terminated ones. That means that here you can actually see that I've been playing with Docker before, and then I've gotten these 3 containers right here. And of course we can also clean those up. by writing docker rm, and then we can then name these containers right here. If we don't want to clean them up by hand, then we can tell our Docker container that it should delete them automatically whenever it stops. Then it should just be deleted because we don't have any information inside them anyway. If we have them, we should volume map the information that is inside them, so we have a volume map instead. So we can do something like this. There's also another way, an easier way. If I run docker rm like this, then I can create some small. It's just a small trick. I can write the dollar, and then I can write docker psaq. This will just give us the IDs, and then we will remove all of those. So now let us try to write docker ps-a. Now we have cleaned up after ourselves. Let us run where we are automatically cleaning up after ourselves. I'll clear the screen right here. Clear. So now we want to do some more stuff, because first of all, we still want to run our Nginx. But now that we know that the latest is automatically added as a tag in the ends, so we don't want to do that. We also want to run this as a daemon, or this terminal is not blocked. That's another thing we want to do. We also want to map out the port 80, and we will map that to the port 8080 on my local machine. We also take 8081. It just needs to be an available port that is available on your machine or on your production server. And then what else do we want? We also want this to be deleted automatically when it's done. Actually, we don't want it as a daemon this time, because I want to press Ctrl+C, and then I want to see that container is actually cleaning up after itself automatically. So first of all, we'll run again so we can see it in the terminal, and then I'll write like this. So now it's actually running again. And if I go here, then I can see that it is running. If I go now to a browser, take my browser now and write localhost, port 8081. Then I get this HTML returned. That's because this port 8080 is actually being routed to or passed on towards the container, my Nginx, that is actually running an Nginx application, which is a web server. It's actually a web server. It's also a proxy server. It can be used for a bit of both. And then I get this beautiful HTML from my Nginx container right here. So this means that now we have an application, a web application that actually works. It provides us some value. It gives us this HTML, and it is running inside the container that we have right there. Now let us go back, because now I want to press Ctrl+C and see if it cleans up after itself. You can also see here when I use the browser, then we got this output here from the Nginx. It actually showed it. It actually said that that we got those returns. There are some icons and stuff that it gave us, and it served the browser. Now let us press Ctrl+C to see what actually happens right here. So go to my other terminal again, then I write docker ps. It is not running anymore. Let us see if it's in the graveyard, so to say. I will run -a to see all. It has been cleaned up now. So even though it has, as soon as it stopped, then it actually deleted itself, and that is because we wrote -rm for them, and that means remove when it's done running. That is pretty cool. No. So the next thing, instead of us, because it is not that nice that we have this. That we have this terminal that is my terminal right here is being blocked by all of this output right here. And if I by accident, or if one of my colleagues by accident press Ctrl+C, then the application will stop. Then the other trick is to run it as a daemon. This means that daemon will just run without taking up this terminal right here. It will run in the background instead. So I will now write -d for daemon like this. And then now let's see what actually happens. So now I have my terminal available again. This means I don't need to start the other terminal again this time. Then I can write docker ps, and then I can see it is actually running right there. That is pretty awesome. But what if I want to go in and check some stuff inside my Nginx image? How would I do that? there are multiple ways of doing that. One is to write docker exec for execute, means that we want to execute a command. Then I can write -it interactive terminal. Then I need to mention the container ID like this, and then I need to say which command we want to run inside my Docker container. And I want to run the shell, so this is just shell. I also run bash if bash is present on inside the container. And now I'm actually inside. The Nginx container right here. So let us just see what we can see here. We can see all the files that we have right here. And we have an Nginx folder right there. And here we can see we have all of our configuration files. We have our Nginx configuration file right there. And here we could actually go and then we could change this configuration file. So instead of giving us the HTML that we just saw before, then we could actually present a custom HTML file instead. Now let us just see what happens if I go to the root again. Now I'm in the root right here, then I say echo tests 1, 2, 3, and then I say I want to paste this inside Mike's file.txt. Now I can see I have Mike's file, it is right there because I just created a file inside the container. But unfortunately, or not unfortunately, that is how it is designed to work. When I stop my container, then the file will be gone forever because I have not volume mapped any folder inside the Nginx container right there. So now I will stop, docker stop, then we'll write docker ps. Now my docker is not there anymore. Let us write docker ps -a. It has also cleaned up after itself, which is pretty nice. Now let us try to volume map it, because if I start up a new container right now, my file will be gone. There will be no Mike's file. So what I want to do is I want to create something called volume mapping, and that is with -v. And then I can volume map something from my local machine. So I have a folder that is synchronized with the container, or I can also just make up a logical name. If I want to make up a logical name, then I just write Mike's volume like this, colon. This means that then I cannot, then it's just a logical volume. It's not a place on my machine, and that is the cleanest way in my opinion, because then you don't mess up your own file system. And then we can say that this should actually map to Mike. So that means that inside the container, a folder named Mike will be created, and we have this Mike's volume that will just also be automatically created by Docker right here. Let us try to run again now. Then we say docker ps, and this time we will use the name. It has a logical name named focus borg. So let us try to run docker exec -it, and then the name of the Docker container. The last time we used the container ID, remember that. Now we are trying to use the logical name instead, and then we write bash. And again, I am now inside the Docker. Now I'm inside Docker container, and look, we have a folder named Mike. So that means, and we can also see that the Mike's file that we created before is gone, because that it's a whole other container. It's like it's a whole other machine that we started up. But there is actually a folder named Mike. So if I go to this folder right here, there are no files right here. I can create some files: file1.txt, file2.txt, file3.txt. I can also echo something inside them. Hello world. Hello.txt, like this. And now we have 4 files inside this folder right here, and I can also try to see what is inside the hello.txt file right there. It is hello world. Okay, so now what I'll do, I'll write exit to exit the container, and then I'll write docker ps, and then I'll stop my this container right here, and just see that it's gone. It is totally gone. and it's also cleaned up after itself because we used the rm command. Now let us try to run a new instance of the same image. That means that we're running new container based on Nginx, but we are still have the same volume mapping, Mike's volume, that maps to the Mike folder. So yes, it is up and running right now. There it is. I'll just clear the screen and docker ps, and then we will say docker attach. That's something else that we can do. Let us just wait for that. We will just finish the volume, file volume first here. Minus IT. Then we say funny Goldberg. Then we say bash. So now we're inside the Nginx container, and then we'll go to Mike's folder. And now we still have the 4 files right there. That means that Docker containers can share files through the volume mapping, and that is used a lot. So especially if you have a database container running, then of course it's very inconvenient that whenever you stop your database container, then all of your data is just being scratched because the database files are gone. But if you volume map the correct folder where the data files are being placed, then when you start up a new container for MySQL, maybe, then your databases will still be there, and then your application can continue using those. So volume mapping is a very important part of being able to use Docker correctly. And of course, also the port mapping is also a very big part of it. And jumping in and out of Docker containers is also a very big part of it, because a lot of times you want to go and debug stuff. You can also write there's a command named logs, and here we have it. If you write docker logs and then the name of the container, then you will get the last lines of output, and you can also follow the logs. Also tail the log, and then every time some new output will come, then you can see it there on the screen. That is also good to know for debugging, especially. And there's another way that we can actually go to the running container, that is with the attach, the docker attach syntax. So we will just write docker attach, and then the name of the container right there. This means now I'm actually attached to the primary terminal output, to the primary control output. That means that if we can create some outputs. Let's go refresh this page a bit, see if it's enough. Yes, look, after we refresh the page, then we actually got some output right here. This also means that if I press Control C now it actually stopped the Docker. So Docker, you should not use attach if you don't have to. You should always use, instead you should execute -IT and then start up a new bash terminal or a new shell terminal inside your Docker container, because else you can stop your application from running by mistake, just like I did there. It was not by mistake, but you can stop your application when you attach to the primary running thread. Okay, so this was kind of the round tour of what we can actually do with Docker with the existing images. But what about what if we want to create our own Docker image? This is exactly an example of that. So I've created a new folder, Hello World, a folder named Hello World. Inside that I have a echo hello once. This means that I want to echo this stuff out here in my terminal. And if you wonder how did I create that hello world, those ASCII signs right there, I'm using a tool named Figlet, and you can just install it with apt-get. If you want to install it, then I can write something like this, and then it will be converted into ASCII code like that, into ASCII characters like that. So that's how I created this run right here, and then I just added echo in front, and then it should echo out this in the terminal. And then when it's done with that, then it will just stop the Docker container, because there are no loops. There's nothing that actually keeps the Docker container from running. If you want a Docker container runs that continues to run, then you need to create some kind of loop where it just continues to where it doesn't stop. if you are a Spring Boot developer, then you would just start your Spring Boot application, and then that would be enough to never stop your application, unless, of course, there's an error inside your application. But what we do is we create a Docker file, and the Docker file is a recipe for how this image should actually, for what did you contain, what should be inside our image. And you always have a from sentence right here. You never stop. You never start from scratch. You can start from scratch if you want to, and then also install the operating system and all that. But usually you would write from and then some kind of operating system. I'm using Ubuntu 21.10 right here. And the reason why I'm doing that is actually just so we can optimize afterwards, because it's a bit heavy, this image right here. It takes up some space, and the more space a Docker image takes up, the less efficient it actually runs when it runs inside the container. The trick here is to try to get these images to be as small as possible. Then I have a command right here that is working directory. That means that I'm setting the working directory inside inside my image to my application. This is just for convenience, because then if I want to copy files, which I want to do in the next line right here, then I copy from, and this needs to be from the same folder or in a child folder. You cannot go up in the file hierarchy. You cannot go up on your own machine and say that you want file two steps up in the hierarchy. You cannot do that. You can only go downwards inside the hierarchy and go into the child folders and then find a file, like I found this file right now here, echo hello once right there. Then I will actually copy it to another file right here, and the file name does not need to be the same. It could just be my application right here. And then instead here in my entry point, then I just name my app in here. The entry point, that is which files, what should happen when we try to start up this container based on this image. What should happen in this case right here? I'm running the shell command -c, because maybe we want to change some commands. And then right now we just want to add and run this one shell script right here. But if I want to run more, then I could just add more arguments out here. And this is an array, as you can see right here. So this is a list of stuff that we want to run. Every time you have a space in your in whatever you want to run, then you need to create that as a new entry in your array. So that is why this. Instead of just writing sh space -c space and then the folder and file name right here, then we need to give it as entries every time there's a space in whatever we want to run. Okay, so how do we now build this image? It is actually quite easy. We just run docker build and then the location of the Docker file, and that is in this folder right here. So I just write dots, which means look for a Docker file inside this folder, and then we give it a tag name. And here it is just Mike's Hello World. Also just say Mike's demo, and then we usually give it a tag like this is. This could like be first version or something like that. First version. And now let us try to run that Docker build image. Let us run that right now. Let's see what actually happens. First of all, if we do not have what is based on the Ubuntu 21.10, then we'll try to download that. First it will download that, and then it will build on top of that image right here. Each line that we have inside the Docker file will actually create a snapshot. This is a way to make it more efficient. So this means that if I just add a new step now, then I could actually reuse the snapshot that I have right here. And then I could just add more stuff that I have here. Maybe I have some more files, copy right here. If you're looking at Stack Overflow or other places, if you're looking in the documentation, then sometimes you will see something like this: add, then a file. You should only use add if you have a zip file or a tar file or a tarball or something like that, because then when you use add and then a zip file, then it will actually automatically unpack that file inside the Docker image. If you do not want that feature, then you should always use copy. And if I used add right here, then I will get the same result, because it's not a zip or tarball. It's just nicer to only use add when you when you specifically want to unpack a tarball or a zip file inside your Docker image. So now we have built, or we can also see the last line right here that went okay, naming, blah, blah, blah. So this means that I have now created my first Docker image right here. So I'll write Docker images. And here I have it, Mike's demo tag first version, and this is the image ID. Was created like a minute ago. It is 77 megabyte big. That's actually not that bad. So using Ubuntu 21.10, it's actually not that bad. It does not leave that big of a footprint. This is definitely acceptable. If you can keep it like below a couple of hundred megabyte, then it's pretty good. Usually, if you start running stuff like apt get update or upgrade or install curl or install a lot of tools, then apt get install -y, and then we can install Figlet maybe. Let's see if we can install Figlet. Then it will get much bigger. Okay, I should have given another tag, but it's okay. As we can see right now it's trying to update all of the existing packages. This will download a lot of stuff inside the image, and it also tries to install Figlet, and then it will also place a lot of stuff inside. So let us write Docker images now. So now it went up to 112 megabyte instead. And it's very easy to get carried away and to create this cool Docker file where it just stores a lot of stuff. But you should always think about the size, especially when you're using the apt-get utility. You can actually say that it should the caching should be disabled, for instance. Then it will not place. Then it will delete all of the packages when they're done being installed. So then you don't have both the installer and also the application itself. So you will only have the application. So now it's 112 megabyte. Okay, I'll just delete these lines again right here. Run. And you saw here I have the run command right here. If you use a semicolon and then a backslash, then you can just add another command on the next line right here. And that is best practice. It is bad practice to have a lot of run commands right here, because every time you create a new Docker image command right here, then you would actually create a new snapshot. So it's the trick is to try to keep the number of snapshots to be as few as possible. I'm going to delete this now, because now we want to optimize even more. I want to write. No, we want to run it, of course. Of course. We want to run Docker run Mike's demo first version. Now I need to give the tag because it is not latest. It is just first version. Now I'll run it, and we can also run it with interactive and terminal, but it does not matter actually. And here we can actually see now we got hello world out of it. Let me just remove IT just for fun. Again, we got hello world out from this. That means that our program works, and we have no running containers right now because it actually stops. There was no loop or anything that actually stopped our shell script from exiting, and we can actually see I'm not cleaning up after myself. It's we have all of these containers in the graveyard right here. If I write -8, and then you can see all of the stopped containers, as well as the one that are also started. Okay, so now we want to optimize a little bit. So then instead of Ubuntu, then I write Alpine right here. Then I will build my application again. Docker build image like this. You can also run it. We can take this line right here, and then we can instead of first version, then we can say Alpine version. This is also a normal thing that some of the image providers, they actually create special Alpine versions that are a bit more lightweight than the Ubuntu versions are. So looks like it works. Let us try to run it. Docker run Mike's demo Alpine. It still works just as well. Now let us try to compare the image sizes. Look here. Look. This is a huge difference here. We have the Alpine 5.5 megabyte. Look, compared to the 112 megabyte, which was the first version that was being created with Ubuntu. There's a huge difference. If you can, then build with Alpine instead of Ubuntu. There are some times where you want to run some things that is actually not, which can be difficult, or sometimes even maybe impossible to install on Alpine. Yeah, but you should really do an effort. Try to install try to get it to work on Alpine first. I hope you liked this video. If you did, then please take the time to like, subscribe, and hit that notification bell, because we have a lot of cool stuff coming up. Bye.